again. We're back with the mouse tutorial today. The mouse tutorial is going to cover how to do inputs using the mouse. We're going to cover the buttons event, the motion event today, and possibly the mouse scrolling event. For right now, we're gonna do mouse button. Let's look at the mouse get state real fast. Mouse state. For starters, the mouse state returns a uint32. This is pretty much just the buttons from it. And it also returns the x and y coordinate. Now, there's another method or function, whatever terminology you want to use, which is SDL get relative mouse state. And the only difference between these two functions, excuse me, is that the mouse relative state gives you the mouse velocity, while the get mouse state returns the actual position. So that's the biggest difference. Similarly, because this tutorial is mostly focused on the event loop, we're not going to be using these functions, but they're still there if you want to use them. I had similar problems with them, especially with handling a first-person camera or third-person camera, because I didn't know about the how powerful the event loop was and the stuff I could handle with it. So, for right now, let's get started. We're going to, for the start of this video, we're going to focus on the buttons. So, let's add two events to it, which are case SDL mouse button down and case SDL mouse button up. We're going to break this for now. How we're going to handle the mouse button is very similar to how we handled the keyboard from the last video. Excuse me. Yeah, like I said before in the last video, I've been sick. Well, let's get back to the tutorial. The mouse can be handled in a similar fashion. For one, we have a SDL mouse button event, so let's create a function that will be a handler for it. It's going to be static void on mouse button event. We're going to pass it a constant SDL mouse button event e, and this is where we're going to handle all mouse button related events. And to keep this in a logical fashion, we're going to put it right under the on keyboard event, and we're going to call it here. So on mouse button event, and we're going to pass it that button. Okay, so because we're handling buttons, we're going to need to know how many buttons we have. A regular mouse has roughly 3 buttons. There's the left click, the right click, and the middle click, or the middle button. So left, right, middle button. So let's make a define statement here called define mouse size, and we're going to put it to 3. Now, there are other mouses out there. My mouse I have in my room is a gaming mouse, and it has, I don't know, 1, 2, 3, 4, 5, 6, 7 buttons, but we're not going to cover that. Let's just stick it with the regular good old-fashioned mouse for now. So similarly to the keyboard, we can reutilize the input state enum that handles state. So let's make that array real fast. So mouse button globals. We're just going to call it actually mouse globals for now. So static input state mouse button state, and we're going to use the mouse size. Excuse me. Sorry. And also very similarly to it, we're going to have mouse functions, and we're going to initialize the mouse, init mouse. We're going to have a mouse button hit and a mouse button press, and they pretty much do the same thing as the key hit and key press, but just for mouse buttons. So static bool mouse button hit, and it's going to be passed an int this time around. Yeah, an int for button, and static bool mouse button press. These functions will do pretty much the same thing. This should only be executed once for the hit, and the press should be continuously execute. So let's copy these and put these down here below the mouse button stuff. So for starters, we need to int I equals 0, I is less than mouse size, I plus plus, and we're going to set the mouse button states I equals is released to make just to play it safe, so we don't have to worry about junk value. And similarly to the previous tutorial, this will return mouse button states I is equal to is only once. Let's copy that, and we'll add another case to the press method. Button states I is equal to is pressed. Okay. And because I want to reuse code, we're going to reuse the check is once method that checks for once. So for int I equals 0, I is less than mouse size, I plus plus. Oh yeah. Oh. That fixes everything. So mouse button states there's an if clause there. If button states I is equal to is once, we're going to set it to mouse button states I equals is pressed. Okay, good. You're starting to see a pattern here, right? The pattern is very simple to follow, and there is one thing we do need to do, and that has to do with the button. And I made a mistake here. Let me show you the SDL button left. I don't know if you can see this hover or not, but this equals to 1. So this means that this will be out of bounds for this array. So a simple solution for this is to button minus 1. I'm not going to worry about that. And button minus 1. There we go. Let me just compile real fast. Oh. Yeah, that's just something silly that Visual Studios is doing. Oh well. Let's not worry about that. So that should be it for the mouse button functions. So now we just need to implement our friend here. Now, on the mouse button event, you have button. The button contains a uint8 that checks for different buttons. So yeah, let's change a couple things real fast. Let's change this to uint8 just to keep it consistent. uint8, and down here uint8 and uint8. So we're going to get the button from this, like we did up here in the onKey event for scan codes. However, we're going to subtract this by 1. Also, similarly, we need the state of the button, so we need east.state equals SDL pressed, and if it's pressed, it will be true, and false if it's released. And I probably should use this the correct signal for it. Okay. So we're going to do the same thing with the if statement up there. And let me quickly write this out. If mouse button states button equals is released, and make it equal to mouse button states button equals is once. If mouse button states button is not equal to is released, then just reset it back to is released. Yeah, pretty much the same for the exception of the subtract 1 for the button. So let's make a quick example for this and say if mouse button press is SDL button left. If mouse button press, or actually hit SDL button right, we're going to do something similar to this little test case up here. But instead of arrow buttons, we're going to just put mouse. There we go. So let's compile our friend here and see if this works. Yep, similar to the mouse, continuously printing out on the left key and one click on the right mouse button. Good. And for laughs and giggles, if mouse button press is SDL button middle, which is the wheel, hello from middle button, middle mouse button. And yay, it works. Cool. Yep, the button portion of the mouse is pretty much the same as the keyboard. It's fairly straightforward. It's pretty simple. Now, let's move on to the next mouse event, which is how we get the position of the cursor. And the event that deals with this is mouse motion. Yep, let's simply break it for now. So we need to go up here and add in a static void on mouse motion event. And like all the other events, we're going to pass it a constant mouse motion. If I can type correctly, I'm really tired right now because I'm continuing making this video after the previous video. Alright, there we go. So let's pop our friend down there. Cool. We do need to have some holding variables for the position of the mouse. So let's go to the mouse global section. We're going to add in static int mouse x and static int mouse y. And we should add an on mouse motion event equals that motion. Okay, so for simplicity's sake, for at the moment, we're just going to simply set the mouse x to equal to the mouse motion event x, and mouse y will equal the y. I'm going to show you how to do relative mouse motion in a minute. So, what we should probably do is do a simple cout of this, and let's do it this way. Mouse X, give it some nice spacing, and mouse Y. Okay. Now what this should do is track the mouse as it goes goes on the screen. So let's compile this real fast. See if this works. See? Cool. Oops. Get over here. Now let's exit that. Okay, good. The mouse motion stuff is working. So now we need to deal with relative coordinates. Now, relative coordinates is pretty much the mouse's velocity. You can easily no, stop that. You can easily get it from this event. Say it's called xrel, and the y subsequently is yrel, or y relative. And what this gives us is the the relative, or I would probably prefer calling it mouse velocity, because if you see right here, you're simply getting the velocities of the mouse. Cool. So, however, we do have a couple things that we need to do. For one, we need to figure out how SDL sets relative stuff. Well, SDL has a function called SDL get relative mouse mode. What this returns is an SDL boolean. SDL has its own kind of boolean value, so we can use this to figure out which type of mouse we want. So if we are in relative mode, we're going to use relative mouse coordinates. Otherwise, we're going to grab the position of the mouse using e.x and mouse y equals e.y. So we can simplify this by adding in a couple functions to deal with. Why are you giving me an error? Oh well, I'm going to forget about that. Let's compile it. So now it should give us just the position coordinates. Cool. So now what we're going to do is create some additional functions to handle relative mode. And what we need is static void set relative mouse mode. It's going to be pass a boolean b static boolean get relative mouse mode, and a simple one just to toggle relative mouse mode. So let's grab these and we're going to create these. Alright, let's go down here. So the first one we're going to deal with is this one, and it's just going to do something like this: if b, otherwise. The next method for dealing with SDL's relative mode is SDL set relative mouse mode. And because if this statement's true, we use SDL true. Otherwise, it's false. This one method or function will return SDL get relative mouse mode is equal to SDL true. So this will return true or false. And this one will do something entertaining, because when you toggle something, you're either turning off or on. So this will be set relative mouse mode, and we're going to basically not the get relative mouse mode. As you can tell by my voice, I'm tired. Sorry. Okay, so we got these implemented, and we're going to add in something fun to here. We're going to add an F key press SDL scan code is tab. Then we'll do toggle relative mouse mode. So Right now we're in regular mode. If we press the tab button, and it's not working. Oh, there it is. Now it's in relative mode. Pretty cool, isn't it? Now there's a couple things I've noticed with the event loop. One, it stays with the the velocities stay the same, which is a no-no. We need to fix that real fast. However, oh, I'm doing a key press, not a key. This should be a key hit. Like I said, I'm tired. So let's fix that real fast. There we go. Cool. Okay. Now the simplest fix is to go in here and we check, because this check is once, we'll just reuse it. This is probably a stupid idea, but oh well. We're gonna get relative mouse mode. We're gonna reset these to 0 and mouse Y to 0. That should fix the issue with it. So if we go here, you see it goes back to 0. Nice. Alright, moving on. There is one more mouse event that we can play around with. And it's something that I rarely use because it's not very useful, but I might as well cover it real fast. And that is the mouse wheel. Now, let's make this real fast. SDL mouse wheel. And we'll just break it for now. The mouse wheel contains a vector, or two values, an x or a y, that contains a velocity value. So let's make those real fast. Int mouse wheel x, and static int mouse wheel y. And like before, we're going to have a static void on mouse wheel event. It's going to be a constant value. SDL mouse wheel event e. Okay. Let's put this where the other handlers are. And let's look at E real fast. Now, the mouse wheel has two values because it also deals with the fact that there's touchpads. Regular mouse usually uses the Y value in here, which will either, if you go up, it's -1. If you go down, it has a velocity of 1. So, because I don't know what kind of system you guys have, we're going to include both of them. So, wheel, mouse wheel x is equal to e dot x, and mouse wheel y is equal to e dot y. And we're going to, as usual, include this function handler, mouse wheel event e dot wheel. Okay, so, and to play it safe, mouse wheel x is equal to 0 and mouse wheel y is equal to 0. Just to make sure that if we move, that it resets itself each frame. Alright, so let's do a simple little test with it. DC out. Let's copy and paste this one down here and comment this one out. Comment this one out. And we're going to replace this one with wheel. Oh, righty then. Let's build this. As you can see, if I'm moving the mouse, it's going, actually it's reverse. If you push up on the wheel, it gives you a velocity of 1. If you do down on the wheel, it gives you a velocity of -1. The reason why X is 0 is because I don't have a horizontal wheel. So the vertical wheel is on the Y and the horizontal wheel is on the X. Alright, now that we have that example done, let's do something interesting. Let's try to move our friend in the box here using the mouse instead of the keyboard. So let me comment this out, and I'm going to comment this stuff out. Okay, now what I want to get is, say, if mouse button hit is SDL button left, I want to grab a vector or create a vector. So let's make a temporary value up here under these test variables. This will be let's include a header file for one of the libraries I have, which is GLM and glm.hpp. What this stuff is it's a linear algebra library. Trust me, you're going to want to grab this if you want to do OpenGL stuff, because it makes life so much easier. So we're going to make it static. Vec2 velocity. Actually, let's do pose static glm vec2 velocity and static glm vec2 cur pose. This will be the current cursor position. This will be the position of the square, and this will be the velocity. So first off, we're going to set pose x equals 32 and pose.y equals 32. We're going to replace our friends here with pose.x and pose.y. So now, when you do a left click, we're going to set cur pose .x equals to mouse x cur pose.y equals mouse y. And the velocity, we're going to have a simple storage vector for now of temp. This is going to equal to, I think, cur pose that is minus pose, and then velocity is going to equal to glm unit? No. don't you have unit? Let me include one more thing. A unit vector is basically a vector with a length of 1. Just let you know if you don't have any linear algebra experience. And it makes for a very great way to do velocities. And I lost my place in the code. Yay! So now let's retry this. New GLM normal temp. Alright. So let's test this real fast. What I want this to do well, it's working, but it's not stopping. Cool. We got some mouse stuff going. The using mouse presses. Let's say if pose.x equal to cur pose and pose not y equal to cur pose dot y. Then I want the velocity vel equals glm vec2, and I'm just going to zero it. Yeah, I'm getting really tired. Do right there, see if it stops. Nope. Yeah. Oh well, it works for the most part. To make it stop, you might want to do a collision box or something. However, let's wrap this up. This tutorial, you learned how to interact with the mouse buttons. They are very similar to how we interacted with the the keyboard from the last tutorial. We also learned how to deal with the mouse motion event, and we know that there's two types of mouse position. One is the absolute position where the mouse is located on the screen. The other one is the mouse velocity, or how rapid the mouse is moving, which is useful, say, if you want to make a first-person camera, for example. You want to use relative coordinates rather than absolute position. And the other thing we learned is how to deal with the mouse wheel event. And you also learn that when I'm tired, I epically fail at trying to figure out how to do mouse motion with the box. It works, but the box doesn't stop. Well, I guess this is it for this tutorial. The next video, I'm going to cover how to deal with the gamepad, which is a whole new ball game, because I've never really played with it in SDL. I've done it before in direct input a long time ago, but this should be a fun experience. So I'll see you then. You all take care.